So in previous session, we discussed that we have a table in first normal form. You can see that this student table is first normal form, and then we normalize it according to second normal form. And in this, we have to decompose it into three tables. We have one table course, another is about student, and third table is on our assigned. In course, we are storing the information of course by having course code as the primary key. In student, we are storing information about students having roll number as primary key, and in our assigned, we are storing course code and roll number. Total are three columns by having course code, roll number as primary key. Now, there are some anomalies still in this table, that is student system charge. So we need to focus on this table a little bit more because there are some problem in this table. So this table is in second normal form, but it has certain problems. So what are the problems in this table? Let's understand that. So this table suffers from insert, update, and delete problem. So insert problem is that, as I have already discussed, roll number is the primary key in this table. So let's suppose I want to insert laptop 40 rupees. I cannot store this rate of the system until I have corresponding student for this particular system. So I cannot store the rate of a system until one student is using that type of system. So this is insert anomaly, that we cannot insert the data of a system without student. So this is the problem of insert. In case of update, let's suppose you want to change the rate of P1 from 20 to 30. You have to make this update operation 2 times, which is equal to the number of students using this P1 system. Same way, in order to change the rate of P4 from 40 to 50, you have to make this change 3 times. So update problem mean that updation of hourly rate for a system require multiple update operation, which is equal to the number of students using these type of system. Similarly, if we remove the data of a student, it will also remove the data of system and its hourly rate. And this problem is worst for a system who has only one student. For example, in case of Cyrix, we remove 109. So this also remove the rate of Cyrix from our database. So due to these anomalies, we have to apply third normal form over this data set. So in third normal form, there are two conditions. So the first condition is relation should be in second normal form. So we know that this table is already in second normal form. So this is true. Now the second condition is there should be no transitive dependent. So no non-prime attribute is transitively dependent on the primary key. Means no non-prime attribute should be transitively dependent on the primary key. So this condition occurs when, so it, in other words, it also means that no non-prime attribute should functionally determine any other non-prime attribute. So when a non-key attribute functionally determine any other non-key attribute, always there is a condition of transitive dependent. And this definition states that there should be no transitive dependence. So the condition is there should be no transitive dependent. So in order to understand, we need to understand what is transitive dependence, because there should be no transitive dependence. So let's understand this transitive dependence by having simple example. So let's suppose we have 3 columns with A as a primary key and B and C as a non-key attribute. Now, B and C are functionally dependent on the primary key. There is no problem in this. But let's suppose we have a dependence between B and C. Here, B is a non-key attribute and C is also a non-key attribute, and we have a functional dependence between 2 non-key attributes here. So if we have functional dependence between 2 non-key attributes, then C is dependent on A by 2 means. One, it is directly dependent on A, and another, it is dependent on A through B. So this through dependence is called as transitive dependence. So this C is, one is it is directly dependent and another it is indirectly dependent through B. So this indirect path is resulted due to this. So whenever we have functional dependence between 2 non-key attributes, always there is a case of transitive dependent. And third normal form said that there should be no transitive dependent. So if you have transitive dependence, you need to remove it. So we have this table, and in this table, we have this table, and in this table, if you draw functional dependence diagram, you know that from roll number is the primary key, so it will functional determine all other columns. but we also have dependence between system used and hourly rate. So this dependence of system used and hourly rate is causing the problem. So this is the diagram here. So you can see that there is a dependence between this. So I can say that this is now A, this is B, and this is C. So there is a dependence between B and C, and this dependence giving a case of transitive dependence. So third NF say that there should be no transitive dependence, but here we have transitive dependence. So this table is not in third normal form. So this is not in third normal form. So in order to convert this table into third normal form, we have to apply rule of decomposition. So this rule of decomposition states that, like, if you have a table like this, so let's go back to this. So if you have table like this, then decompose into AB and BC. So decompose this decompose, there is a dependency between B and C. So create a separate table for BC and one table for A and B. So if you have situation like this, can you tell me how many tables need to be created in this case and what are those tables will be?
Sir, two tables, A, B or C, or X, C or D.
So in this case, we have to create one table for this dependency and another table will for all remaining, that is A, B, C. And you know that by joining C and C, you can get the original table back. So you can join both the tables on C column. So if we apply this rule over this, so I need to make one table for this and one table for system and hourly rate. So this way we decomposed this table into two. So one is roll number, name, and system used. This is the table. And another is system used and hourly rate. So all the problem of insert, update, delete has been solved by decomposing this table into two tables. You can insert the data of laptop 40 rupees in this table without having corresponding student. In order to make changes in the hourly rate, you need only one update. And if you remove the data of student, it will not affect the data of system because both are independent tables. So we are able to solve the problem by converting this table to third normal form. So ultimately, this is the original table which we have in first normal form. So this table is finally decomposed into four tables. One table is course, which acts as a course master. Another is student master, roll number, name, system. System master with system and charge, and are assigned. So we finally have four tables, and this database is finally normalized up to third NF, and there is no problem in this. And we discussed that 90% of databases are normalized up to third NF. So this is very powerful normal form, and most of the databases are normalized up to third NF. So this was the point. If you have any doubt, you can ask me any question. So now we are going to discuss about our new concept, that is BCNF. So let's start discussion over BCNF. So BCNF is actually designed to solve a very special case. So what is that special case? Let's discuss that. So let us consider this table first. So if at any moment you have any problem, just interrupt me and you can unmute yourself and ask me any question. So in this table, we have four columns. This is the data about a manufacturer. This is the data about a company which has some fixed ID number. This is the name of the company, and every company has a registered name. So this company M101 has a registered name, let's suppose Electronic USA, and this M32 has another name called as Electronics RUS. So this name is unique, and these are the registered name of the company. For example, if you have a company named Philips, no other company can has registered by using the same name. So if you have a company with Samsung, no other one can register as Samsung. So it means that here name of the company is also unique as ID number. So this is the point which I want to make at this point, that these are the registered name of the companies, and you know that registered name of companies are also unique as the name of the ID. For example, there will be only one Philips in the whole world. There will be only one Samsung in the whole world. There is Same way, so here we have same one fixed name for a particular company, and I am assuming that this name is also unique. Now, one company can manufacture multiple items. You know that Philips can manufacture 3 or 4 items. So let's suppose that these are the 3 items which are manufactured by this company. And of course, the manufacturing quantity will be different for each of the items. So let's suppose M101 is manufacturing this item in this quantity, another is this item in this quantity, and same way it is manufacturing 3 items in different quantity, while this company M32 is only manufacturing 1 item with their corresponding quantity information. So now, let's suppose that I have to create this table, and I create this table. So in this particular situation, do you feel that there is some insert anomaly in the table, or there is some update anomaly, or there is some delete issue in the table? So can you find out some insert anomaly in this table? Anyone? Can you find some insert anomaly in this table? If I create this table, what problem I will get? Okay, in order to address it, you need to identify the primary key of this table. So what will be the primary key of this table? What is your thought?
Combination of ID number and item number.
So combination of ID number and item number is primary key. So let's make it clear that this is combination is primary key. So based on that, now give me a thought. What will be the problem of insert? So let's suppose I have a company who is not manufacturing any item right now. Can I store the data of that manufacturer? Or is it possible to have a manufacturer who is not manufacturing? So there may be some situation that you may have a manufacturer who may not be manufacturing throughout the year. For example, there are some seasonal product. So if you have some seasonal product, then that company will be manufacturing only for 4 months and then selling it for the whole year. So this is very natural that one company may not manufacture any item at a particular point. So they may manufacture only for fixed months only. They may not manufacture through whole year. So this is very natural because it is based on the orders. So they normally get the order maybe during the start of the winter. So they only start manufacturing during those fixed month. So let's suppose you have a company who is registered, but that company is not manufacturing any item right now. Can you store the data of that company?
No, sir.
So we can't store because for every company we should have corresponding item number. Now let's suppose you want to change the name of the company, then how many update operation you need to make? Sometimes you see that there are changes in the name of the company. So if I have to make change in the name of the company like M101, how many update operation I need to make? It will be multiple, which is equal to the number of product that company is manufacturing. So there is a problem of update operation because you can see that M101 is repeating 3 times. So if there is a change in the name of this company, I have to make that change 3 times. And same way, you can understand the problem of delete. If you delete the data of a company, it will also delete the, for example, this M3. For example, this M322 is manufacturing H3772. But now they stop manufacturing this. So if they stop manufacture this, you have to remove the rows. So if you remove the row, you will also lose the information about the name of the company. So if some companies stop manufacturing a particular product, you have to delete the row, but that will also causes deletion in the information about name of the company. So these are few cases where you can clearly think that there are some issues in this table. Regarding insert, update, and delete. Again, I am repeating. So I cannot insert the data of a company who is not manufacturing any product. For example, I can't store that M1000 is company XY, but that company is not manufacturing any product. So I can't insert that data. In order to make change in the name of the company, I have to make multiple update, which is equal to the number of item it is manufacturing. And if some companies stop the manufacturing of a particular product, I have to remove that row, but that also causes deletion of the removal of the name information of the company. So due to this problem, we have to ultimately normalize this table. So in order to normalize this, we have to start from first normal form. So can you tell me, is this table is in first normal form? Can you tell me, is this table is in first
No,
normal
sir.
form? Is it in first
Yes,
normal
sir.
form? Is it in
Yes,
first
sir.
normal form or
Yes,
not?
sir.
Yes,
Yes,
this is
sir.
in first normal form. There is no repeating group. You can see that for every row column combination, we are getting one value. So there is no problem to say that this is in first normal form. There is no issue in that. Now, give a thought about second normal form. Is this database is in second normal form? Can you identify the in order to look for second normal form, you have to create FD diagram. So in order to build FD diagram, you have to look for primary key. So this is the primary key, you know that. So can you build the FD diagram for this? So if this is the table, so what will be the FD diagram? So FD diagram, we have to make primary key. So the primary key is ID number and item number. So this is combination is primary key. Other attribute is name and another attribute is quantity. So now can you tell me this name is dependent on which column?
ID number.
So
ID
name is
number.
dependent on ID number. Okay, and what about quantity?
Combination.
Quantity is dependent on combination. Do we have any other dependent in this? Any other dependency? There is one more dependency in this table.
ID number and name.
So ID number, name, and the reverse is also true because name is unique. For every name, you will get only one ID number. So you know that. So name is also unique in this table. I have already told you that this is the registration number of a company and it cannot be same for two companies. So it means that from name you will get one ID number and from ID number you will get one name. So from this discussion, you can see that ID number and name are replaceable. You can replace each other because both are unique, both have same capabilities. So if ID number and name are replaceable, can you think that there is one more possibility of the FD diagram? Then there is one more possibility of FD diagram. So I have represented one possibility, but there is one more possibility. Can you identify what is that possibility? Because
name और ID number को swap कर दो.
Name और ID number को interchange कर दो.
So you can also make name and item number as primary key because both are same, both have same capability. So if you are saying that ID number and item number combination is unique, then this is also true for name and item number because name is also unique and name and item ID number are replaceable. So you can replace it and it can become like this. So if you make this as a primary key, then ID number will become here, quantity will be here. So name to ID number to name, and this is the quantity which is fully functional dependent on this. Okay, so now in this examples, first time we are getting two FD diagram. This is FD1, this is FD2. So we are getting two FD diagram for this particular problem statement. And this particular problem statement, if you apply second normal form now over this definition, so what is the definition of second normal form? Do you remember it? And what is the rule for that? So second normal form state that a relation is in second normal form if and only if it is in first normal form. We know that it is in first normal form, so it satisfied that definition. Second statement is that all non-key attribute should be fully functional dependent on primary key. मैं यहाँ लिख देता हूँ, non-key attribute should be fully functional dependent on primary key. So it should be dependent on combination. It should not be dependent on any subset, but this is only true for non-key attribute. So now, can you tell me how many non-key attribute we have in this FD diagram? So what is non-key attribute?
Sir, quantity.
So we have non-key attribute as quantity. Do we have any another non-key attribute?
पहले केस में name और second case में ID number.
So you can give a thought about name. You can think that name is a non-key attribute, but here there is a one interesting case that name is not a non-key attribute because it can participate in the primary key. So this is first time we are not getting name as a non-key attribute because it can participate in the primary key. As you can see in FD2, here name is a key attribute, while ID number and ID number is a non-key attribute here, but here it is a key attribute. So you can see that here we are getting a something very special case, and that special case is called as overlapping of candidate key. So this case is called as overlapping of candidate key. It means that we are getting two candidate key. You know that this is unique combination and irreducible. So I will call this as a candidate key. So this is candidate key 1 and this is candidate key 2. So we are getting two candidate key. And out of these two candidate key, one column is common. You can see that item number is common in both the cases. So when you have two candidate key and one column is common, we called this at overlapping of candidate key. And whenever we have overlapping of candidate key, you will get this problem of non-key attribute. Then you can't say this as a non-key attribute because it can participate in the primary key because you are having two candidate keys. Then you cannot say this as a non-key attribute because this can be a part of candidate key or primary key, because here you can see that ID number and item number is the primary key. So we have only one non-key attribute, that is quantity, in this definition. So according to this definition, is this database is in second normal form?
Yes, sir.
Yes, because we have only one non-key attribute, and that non-key attribute is fully functional dependent on the primary key. Here we have only one non-key attribute, and that non-key attribute is fully functional dependent on the primary key. You can discuss this, but this is not a non-key attribute. So the problem of second normal form is that it only addresses non-key attribute, but sometimes this may not be acting as a non-key attribute. When this happens in case of overlapping of candidate key, as I have drafted an example for this. Now, is this database is in third normal form? Is this database is in third normal form? Third normal form simply state that no non-key attribute should depend any other non-key attribute. There should be no dependence between two non-key attributes. Here we have only one non-key attribute. So there is no question of transitive dependence. Transitive dependence can only happen if you have two non-key attributes. Here you have only one non-key attribute, so there is no chance of transitive dependence. So this database is satisfying the definition of third normal form as well as second normal form, because this is a special case of overlapping of candidate key when you can't say this as a non-key attribute because it can be a part of primary key, and you cannot say this as a non-key attribute because it can be a part of primary key. So this is a special case of overlapping of candidate key, and whenever you have overlapping of candidate key, your second and third normal form fail. And then in order to solve this problem, Boyce-Codd, he is the name of the scientist who identified this problem and suggested another normal form to handle that situation. And that normal form is called as Boyce-Codd Normal Form, or BCNF. So this is the alternative to third normal form. So there are some situations where third normal form fail. When third normal form fail, it fail in case of overlapping of candidate key. What it mean? You have two candidate keys and one column is common in this, then we called it as a overlapping of candidate key. And whenever you have overlapping of candidate key, you cannot say this as a non-key attribute or this as a non-key attribute because it can participate in the primary key. So you have only one as a non-key attribute, and this non-key attribute is fully functional dependent and there is no transitive dependence. So this data is in second and third normal form, but we know that still there are some problem in the database, but we can't solve these problems with the help of second and third normal form. So we have something called as BCNF to solve that problem. So BCNF solve this problem by having very simple definition. And it simply states that a relation is in BCNF if and only if every determinant is a unique or a candidate key. So BCNF does not refer to second normal form or third normal form. You see that second normal form refer first normal form. Third normal form definition refers to second normal form. But BCNF does not refer to any first or second or third normal form. It simply states one simple rule that every determinant should be unique or every determinant should be candidate key. Now the question is, what is this determinant? So in order to understand what is this determinant, let's consider a table with the functional dependence x to y. So in this case, what is determinant? Can you tell me? In this case, x is determinant. So the column from where the pointer originate is called as determinant. And this BCNF state that the determinant, the point from the column from where the pointer emerge should be unique, or in simple word, it should be candidate key. If it is not, decompose it. If it is unique, then it's okay. So this is the simple definition. So let's do this for our data set. So here we have this FD diagram. So can you tell me how many determinants we have in this table? How many determinants we have in this table? Determinants mean the column or combination of column from where the pointer emerges. So can you tell me?
3.
So we have 3. Can you name me that? One is?
Combination of item number and ID number.
So one is combination of item number and ID number. Another?
ID number.
ID number. Very good. You can see that here ID number. Okay. And next?
And name. Name.
And name. So we have 3 determinant in this table, and BCNF state that these determinants should be unique or candidate key. So we have to check this for these 3 columns. So let's check first for this combination, ID number and item number. So we have this table, ID number and item number combination. So is this combination is unique? ID number, item number, is this combination unique? Yes, we know that this is the part of primary key. Yes, this combination is unique. We have one more combination which we missed. So we have actually 4. Can you tell me what is the 4th one? Anyone? We have 4. 4th one is item number
And name.
and name. So out of these 4, you know that this is unique. Sorry. Out of this, we know that this is unique and this is also unique because these are the primary keys, possible primary keys, or these are the candidate keys. But ID number is repeating and name is also repeating in my data set. So if you look into your data set, you can clearly see that your ID number is repeating and your name is also repeating. But BCNF state that out of these 4, everyone should be unique. So your ID number should be unique, your name should be unique. This combination ID number, item number should be unique, and name and item number combination should be unique. But I have only these 2 combination unique in this table, but ID number individual is not unique and name individual is not unique. But BCNF state that a relation is in BCNF if and only if every determinant is unique. So I have 4 determinant. Out of these, this first and last determinant are unique, but ID number is not candidate key and name is also not candidate key. So in order to make this candidate key, you have to decompose your table in such a way that ID number and name should become unique. So you have to decompose your table in such a way that they should become unique. So what is the way to decompose it? You can simply decompose it by having 2 tables. So what are those 2 tables? So we have this, and I have to make ID number and name unique. So in order to make this table unique, I will create one table for ID number and name, and another table will be ID number, item number, and quantity. So I will create 2 tables. One is ID number and name. So here both are unique. So I will store only 2 records in this. So this will solve the case. And another table I will create ID number, item number, and quantity. And this way I will able to solve. So this table is in BCNF. You know that ultimately we have to decompose this way only. if you apply second normal form, you know that you have to decompose ID number and item number in a separate table. But we were not able to do this because this is not a non-key attribute. So we have to remove this, but we were not able to remove it because this is not a non-key attribute. So it passes the condition of second normal form and third normal form. So, but BCNF captured that particular point. It simply states that don't bother about fully functional dependence, non-key attribute. Simply check that every determinant, the pointer, from where you are getting the pointer, it should be unique. So if your starting point of the pointer is unique, then there will be no problem. And if it is not, there will be a problem. So this is the point. Now I'm going to apply this on this FD diagram to make this point a little bit more clear to you. So let's apply this. So you know that we have this table and we normalize this table by using second and third normal form. Now I can directly apply BCNF over this. So without bothering about second and third normal form, I can also normalize this by using directly BCNF approach. So you know that this is the FD diagram of this table. So can you tell me what are the determinant in this table?
So roll number.
So one is roll number. So I will write here. So one is roll number. Another is
Course code.
another is course code. Third one is roll number and course code combination. Do we have one more?
System used. System used.
So you can see that BCNF state that a relation is in BCNF if all these four columns are unique in your table. So you have to make roll number unique. You have to make course code unique. You have to make roll number course code combination unique, and you have to make this system used unique also. If this system used is not unique, there will be some problem in the table. So initially we decompose our tables like this way. So when you decompose our tables in this way, then you got FD diagram or table like this. So here you can see that your course code become unique. So here course code become unique. Here course code roll number combination become unique. Here roll number also become unique. But still system used is not unique. You can see that P4 is repeating. So due to this, this table is not in BCNF. So BCNF state that there is a dependence between system used to hourly rate and system used is a determinant. So this determinant should be unique. So in order to make this system used unique, you have to decompose it into further tables. So ultimately you got these tables where you have four determinant and all the four determinant are unique. In this system used determinant is unique. Here roll number is another determinant, course code is determinant, and this combination is determinant. So ultimately we have done the same thing. So we can directly apply BCNF to the tables which are normalized with the help of second and third normal form. And BCNF can also fulfill those situations where second and third normal form fails. So we can say that BCNF is better as compared to 3NF because it can solve those situations where 3NF work. But plus it can also solve those situations where 3NF fails. So you know that 3NF fails in case of overlapping of candidate key, because in this case you have two candidate key and one column common. Then you can't call this name or ID number as a non-key attribute, and due to this, this table is normalized according to second and third normal form, but still it has problem. So in order to solve that problem, we applied BCNF. We simply state that a relation is in BCNF if every determinant is a candidate key. What is determinant? That X should be unique or candidate key. So we applied this. We checked that we have four determinant. Out of these, this combination is unique, this combination is unique, but we have determinant ID number and name, but these determinant are not unique. So in order to make it unique, you have to decompose into two tables, and ultimately we are able to solve the problem by using BCNF. And we have also learned that if we apply directly BCNF over this data set, then again you will able to get the same table which we achieved after second and third normal form. So in the end, I can conclude that BCNF is better as compared to 3NF because it solves all the problems of overlapping of candidate key, as well as normal database can be normalized with BCNF also. So this is the concept. If you have any doubt, you can ask me any question.